Welcome you all to the virtual lab discussion. Today we will discuss on load test on three-phase alternator. Now drag this experiment to the workspace and you can see the circuit diagram of this experiment below which the abbreviation and the ratings of the DC shunt motor and the alternator is given. And in this circuit diagram, the one end of the voltage changer is connected to the DC input power supply through double pole single switch, and the other end is connected to the DC shunt motor, and in which the DC shunt motor is coupled through two alternator, and the output of the alternators is connected to the load, and the input is connected to the field excitator. Let us now start our experiment. The DC shunt motor is coupled to alternator, which acts as a prime mover. By closing this switch, DPST switch, the current starts to flow in the DC field winding, which gives output as mechanical, which acts as a rotor to the alternator. And after that, by closing this field alternator, I mean field excitation, you can see some variation in the output voltage. That is due to some residual magnetism in field winding of the alternator. And now let us close this DPST switch. The current starts to flow. We have to increase the voltage to the rated RPM. I mean to get the rated RPM in the alternator, and the rated RPM of an alternator is 1500, that is given below. Speed is equal to 1500 RPM. So by clicking this you can increase the current and also the speed. You can see here it goes on increasing. The rated speed is set. After this, the field excitation of the alternator is applied by closing the DPST switch and making this to, to the rated voltage of an ammeter, that is given below. Armature voltage is 415 and this to be read here. As I told, there is some voltage. This is due to some residual magnetism in the field winding, and you can see there is zero current. So by clicking here you can increase the field current, and also there is some voltage change in the output, and we have to set this to the rated armature voltage, that is 415. You get the rated voltage 417. You can see these three are getting the same voltage, and you can see here the current in this is zero in all those three. This is due to there is no load is connected. By closing this you can increase the load one by one, and first we will take the reading for no load, that is start storing data and then show data. For no load test we are getting this, and for one by one we are going to increase the load. Now we are giving the second load to each output, and we are storing the data and we show the data. Like this we are going to repeat for all other loads. And down we got all other readings of full load test, from no load test to full load test. And here you can select any graph. Like first I'm going to give the output alternator versus efficiency and give click to generate graph. You can see down here the graph between output alternate versus efficiency. Likewise, we can select any other graph, that is for output alternate versus voltage regulation, and the output alternate versus speed. For every other graph we can choose what graph we want, we can choose. From this experiment we can find the efficiency and the regulation of an alternator. This is done by driving the alternator to its rated speed and increasing the field excitation current till the armature voltage reaches its rated value. By introducing load to the alternator, we can see the changes that armature current will increase and the armature voltage would change according to the load given. Observing the input and the output of the alternator of each load, we can find the efficiency and regulation of an alternator. Thank you.